Hi, I'm Lindsay. I'll be doing on algebraic calculation on circle. And first, I'll be saying, what is a circle? So, a circle is simply a set of points that is from a constant distance from a fixed center point. First, we set our z0 to 3 plus 4i, and we set our r equals to 2. Then, after that, we substitute into this formula, then we got x minus 3 squared plus y minus 4 squared equals to 4. Done. Then we find our magnitude of z0, which is equal to 5, and our z minimum, which is equal to 3, and our z maximum, which is equal to 7. Moving on to our verification on z minimum and also z maximum. Then we got our z minimum, which is 905 plus 1205i. Also our z maximum of 2105 plus 2805i. Moving on to our magnitude of z minimum and also our z maximum, and we got the value of z minimum, which is 3, and also the value of z maximum, which is 7, and it's same as the one before, so it's verified.
Hi, my name is Patience. This question is about finding the maximum and minimum argument of a complex number. So first, I rewrite the given equations x minus 3 squared plus mx minus 4 squared equal to 4. After expanding, I will get the equations 1 plus m squared x squared minus 6 plus 8mx plus 21 equal to 0. To ensure the line just touches the circle, I will set the discriminant equal to 0. Solving this, I will get two values of m equal to 4.233 and m equal to 0.567. Since the argument of z is arctangent m, so the maximum argument is 76.7 and the minimum argument is 29.5. So I sub y equals x into the equations, and then after simplifying, I will get the equation 7 plus 16m squared minus 70x plus 63 equals 0. So I use b squared minus 4ac equals 0. And then I solve for m, and I will get m equal to plus minus 7 over 9. Then the maximum argument is 41.4 and the minimum argument is negative 41.4.
Now we are going to do the GeoGebra illustration. As we can see here, there's one circle with the center of 3, 4 with the radius of 2, and one more circle at the center of 0, 0 with the radius of r. Now we are going to find the z minimum and z maximum. As we can see here, the z minimum is equal to 3, while the z maximum is equal to 7. Now we are going to find the minimum argument of z and the maximum argument of z. Now for the maximum, we have the point B here. We calculated and we got the angle is equal to 76.699 degree. While the minimum argument of z, we have the point E here. We calculated and we got the angle is 29.565 degree, which are approximately accurate to the algebraic calculation.
Moving on to part B, the elliptical locus. I'm Alicia and I'll be explaining B1, the algebraic calculation.
First, I'll set my point into z1 equals 2, z2 equals 8, and k equals 8. By setting the sum of distance to 8, we get this equation. That is geometrically represents the ellipse. Twice to eliminate the radicals. And after simplifying the algebra and completing the square, I arrive at the quadratic form. And we find the ellipse center 5, 0. And a equals to 4, b equals to 7. So for the modulus extrema, I define the distance square function b square equals to x square plus y square, and substituted the parametric form. In the derivative, I found that the critical point was outside the valid range of cosine. This means that the extrema must result in a range where delta is 0 or pi. And this results in the maximum modulus of 9 and the minimum modulus of 1.
Hi everyone, I'm Shuben. I talk about B1 argument extrema on ellipse. So we start in y to mx and we get bracket 7 plus 16m squared times x squared minus 70x plus 63 equal to 0. We use b squared minus 4ac to find the m values. And then m values are 0.8819 and negative 0.8819. Max arc z will be 41.4 degrees, mean arc z will be negative 41.4 degrees. Now we find x and y. X is 9 over 5, y is plus or minus 3/7 over 5. Tangent points are 1.8 plus or minus 1.587i. And then we verify z plus in the ellipse by subbing the value into the ellipse formula and we get 1. It's correct.
Okay, now I will continue with the GeoGebra illustration. So here is our ellipse. We use the sweeping circle to justify our z minimum and z maximum. So first it touches the ellipse at exactly z equals to x equals to 1. So z minimum is 1, which matches our calculated value. So as we expand the sweeping circle until it touches the ellipse again, it touches the ellipse again at exactly 9. So that is our z maximum. And then for the argument, we use the tangent line function in order to get the intersection here, which match our calculated value. So then that leads to our argument answer 41.41 here, which match our calculated value. So that's it. Thank you.